Estimating the load current of an existing air conditioning unit when you lack direct access can be challenging, but there are methods to arrive at a reasonable estimation. Let's consider a scenario involving a three-phase, 240 volts air conditioning unit on a rooftop with difficult access. It's supplied by 3 number 10 wires protected by 30 amps fuses. The goal is to estimate the load current to determine the air conditioning compressor load that these 30 amps fuses can supply. It is important to note that any estimation is not as reliable as physically inspecting the equipment in person. The following methods do not replace physically inspecting and measuring the load and nameplate data from the equipment. Firstly, let's use the fuse ampacity and voltage to estimate the load. The ampacity of a fuse represents the maximum current it can safely handle without blowing. In this case, FR&R fuses are used, and their ampacity is 30 amps. We can employ Ohm's law to calculate the maximum load current. The formula is load current equals fuse ampacity divided by line voltage. Therefore, we can substitute the values load current equals 30 amps divided by 240 volts, which equals 0.125 amps. Therefore, the estimated load current for the A/C unit is 0.125 amps based on this method. Secondly, let's consider using typical A/C compressor amperage. Typically, an A/C compressor draws between 3 and 5 amps per ton of cooling capacity. Assuming the unit is a standard efficiency model, we can estimate the load current based on its tonnage. Let's assume the unit is a 3-ton air conditioning unit, a common size for residential buildings. The estimated load current can be calculated as load current equals 3 tons multiplied by 4 amps per ton, which equals 12 amps. Thus, using this method, the estimated load current is 12 amps. In conclusion, based on these calculations, the estimated load current for the existing air conditioning unit ranges between 12 and 0.125 amps. Given the limitations and uncertainties, it's safer to use the higher estimate of 0.125 amps for planning purposes. Keep in mind that these are only estimates. The actual load current can vary based on the specific model, condition, and operating conditions. For a precise estimate, inspect the unit's nameplate or consult an HVAC professional. The NEC, or National Electrical Code, covers important regulations. Article 430 covers motors and motor circuits, including air conditioning compressors. When sizing conductors and overcurrent protection for motor circuits, the NEC provides specific guidelines to ensure safety and proper operation. NEC Section 430.22 addresses the minimum size of conductors for motor circuits. It requires conductors to have an ampacity of not less than 125% of the motor's full load current rating. This accounts for the motor's potential to draw more current during start-up and varying load conditions. Additionally, NEC Section 430.52 outlines the requirements for motor overcurrent protection. It specifies the maximum rating or setting for overcurrent devices such as fuses or circuit breakers based on the motor's full load current and design characteristics. The type of motor and its specific application will influence the selection of appropriate overcurrent protection. For air conditioning compressors, which are typically hermetic refrigerant motor compressors, NEC Section 440 provides supplementary guidelines. This section addresses the specific requirements for air conditioning and refrigeration equipment, including sizing conductors, overcurrent protection, and disconnects. When dealing with air conditioning compressors, it is essential to consider the compressor's nameplate data, which includes the rated voltage, full load amps, locked rotor amps, and other pertinent information. This data is crucial for accurately sizing conductors and overcurrent protection. In the absence of a readily accessible nameplate, estimating the load current becomes necessary, as discussed earlier. However, it is important to acknowledge the limitations of estimations and to prioritize safety and compliance with the NEC. In such cases, it is recommended to consult with qualified electrical professionals who can assess the situation, perform necessary measurements, and provide accurate guidance based on the specific equipment and installation conditions. Remember that the NEC is a comprehensive set of regulations that aim to protect people and property from electrical hazards. Adhering to the NEC requirements is essential for ensuring the safe and reliable operation of electrical systems, including air conditioning compressor circuits. When dealing with electrical installations, prioritize safety and accuracy. If you are unsure about any aspect of the installation, seek assistance from qualified electrical professionals who can provide expert guidance and ensure compliance with the NEC and other applicable codes and standards. Always remember to verify the actual voltage of the equipment itself to ensure any voltage drop considerations do not impact the operational capacity of the equipment. When assessing the existing installation, carefully evaluate the condition of the existing wiring and equipment. Look for signs of damage, deterioration, or improper installation. If any issues are identified, address them promptly to ensure the safety and reliability of the electrical system. Consider the age of the air conditioning unit. Older units may have lower energy efficiency and higher operating costs. If the unit is nearing the end of its lifespan, it may be more cost-effective to replace it with a new, energy-efficient model. When evaluating the existing electrical system, assess the capacity of the electrical panel and service entrance. Ensure that they have sufficient capacity to handle the additional load of the air conditioning unit without overloading the system. If necessary, upgrade the electrical panel and service entrance to accommodate the new load. Evaluate the existing grounding system to ensure that it is adequate and in compliance with the NEC requirements. Proper grounding is essential for protecting against electrical shock hazards and ensuring the safe operation of electrical equipment. Consider the location of the air conditioning unit and its accessibility for maintenance and repairs. Ensure that there is adequate clearance around the unit for servicing and that it is easily accessible for technicians. If the unit is located in a difficult-to-reach area, consider relocating it to a more accessible location. When selecting a new air conditioning unit, choose a model that is energy efficient and meets the cooling needs of the building. Look for units with a high seasonal energy efficiency ratio, or SEER, rating and an Energy Star certification. These units will save energy and reduce operating costs. Ensure that the new air conditioning unit is compatible with the existing electrical system. Check the voltage, phase, and amperage requirements of the unit to ensure that they match the existing electrical service. If necessary, make any necessary modifications to the electrical system to accommodate the new unit. When installing a new air conditioning unit, follow the manufacturer's instructions and the NEC requirements. Ensure that all wiring connections are properly made and that the unit is securely mounted. Use appropriate overcurrent protection devices and disconnect switches to protect the unit and the electrical system. After installing the air conditioning unit, test it to ensure that it is operating properly. Check the cooling performance, airflow, and electrical parameters. Verify that the unit is not drawing excessive current and that the voltage is within the acceptable range. Periodically inspect and maintain the air conditioning unit to ensure that it continues to operate efficiently and reliably. Clean the coils, check the refrigerant levels, and lubricate the moving parts. Address any issues promptly to prevent them from escalating into major problems. Consider installing a surge protection device to protect the air conditioning unit from voltage surges and spikes. These devices can help to prevent damage to the unit's electronic components and extend its lifespan. Use a licensed electrical contractor to perform any electrical work related to the air conditioning unit. Licensed contractors have the knowledge, skills, and experience to ensure that the work is done safely and in compliance with the NEC. Obtain all necessary permits and inspections before starting any electrical work. Permits and inspections help to ensure that the work is done properly and that it meets the applicable codes and standards. Document all electrical work that is performed in the air conditioning unit. Keep records of the wiring diagrams, circuit breaker sizes, and other relevant information. This documentation will be helpful for future maintenance and repairs. When working with electricity, always prioritize safety. Wear appropriate personal protective equipment, such as safety glasses and gloves. Energize the circuit before working on any electrical components. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Be aware of the potential hazards of working with electricity, such as electric shock, arc flash, and electrocution. Take precautions to avoid these hazards and to protect yourself and others from injury. Familiarize yourself with the NEC requirements for electrical safety. The NEC contains important information about safe electrical practices and procedures. Follow these requirements to ensure that you are working safely and protecting yourself from electrical hazards. When in doubt, consult with a qualified electrical professional. Electrical work can be dangerous, and it is always best to err on the side of caution. If you have any questions or concerns, seek assistance from a qualified electrician or electrical engineer. They can provide expert guidance and ensure that the electrical work is done safely and in compliance with the applicable codes and standards. Always verify all aspects of the electrical work. Using properly sized fuses and conductors are critical for safety. Consider the ambient temperature of the location to ensure proper sizing of electrical elements and equipment. Understanding the different types of conductors and fuses is important. There are many types of each, so use the correct one for each application. The NEC is updated every 3 years, so make sure you are up to date with the latest version. Many jurisdictions also have local electrical codes. Make sure you know what your local codes are and comply with them. It is important to remember that electricity can be dangerous. Always take precautions when working with electricity and follow all applicable safety codes and regulations. Remember to consult a qualified and licensed professional when dealing with electrical work.